What is antimatter? Antimatter, much like matter, is made up of elementary particles, except antiparticles. But what does this mean? Elementary particles can effectively pop in and out of existence, as they are just excitations of their respective field. For example, an electron is just an excitation of the electron field. However, due to conservation of charge, whenever a particle is brought into existence, its corresponding antiparticle must also come into existence. This antiparticle will have opposite charge to the particle, so while an electron has a charge of -1, an anti-electron, also known as a positron, has a charge of +1. The mass and spin of both are the same. Antimatter should exist in equal amounts to matter in our universe, but we don't see this. The reason why is still a mystery. Antimatter still exists in small amounts in our universe, including in our own solar system, and we can create antimatter from particle collisions and from certain types of radioactive decay. We can theoretically use antiparticles to assemble anti-atoms, and from there, anti-everythings. Now, according to Einstein's famous equation E = mc², mass and energy are equivalent and interchangeable. If a particle and its respective antiparticle collide, they annihilate and release the equivalent amount of energy for their combined masses. This means 100% of mass is converted into energy, as opposed to just 0.1% of mass via fission of uranium-235. And yes, that last one is what powers nuclear bombs. If we were to theoretically make a bomb powered by the annihilation of a kilogram of antimatter with a kilogram of matter, the resulting explosion would be an energy release of over 180 quadrillion joules of energy. In fact, due to its unique property of converting 100% of mass into energy, annihilation of matter with antimatter could one day be used to create the most devastating weapons mankind has ever known. It could also be used for more efficient space travel, blowing apart dangerous asteroids, various medical applications which are already in use, or quite simply for storing colossal amounts of energy in highly compact spaces, like a battery. There, however, are some obstacles to using antimatter. The first one is storage. If we even had just a gram of antimatter, or even a fraction of a gram of antimatter in the room, it would instantly annihilate with the matter in the air around it and cause a deadly explosion. We could store the antimatter in a vacuum so that it isn't in contact with any matter. However, the antimatter can just drift to the sides of the container and then explosion. One solution is to use a superposition of electric and magnetic fields to hold charged antimatter in the centre of the vacuum, preventing it from moving about. This device is known as a Penning-Malmberg trap. However, we would still have problems with creating a perfect vacuum and ensuring that the inner container doesn't just shed matter onto the antimatter, so therefore we can't currently store antimatter for very long. The second issue is with obtaining antimatter. There isn't a lot of antimatter floating around in our observable universe, and our current methods of producing antimatter are highly inefficient. However, there is hope. The NASA Institute for Advanced Concepts is considering the far future possibility of using magnetic fields to capture the positrons and antiprotons that naturally occur in the solar system, such as in the Earth's Van Allen belts and in the belts of gas giants. These comparatively smaller antimatter deposits are thought to have arisen from naturally occurring high-energy particle collisions and from nuclear reactions, for example from beta-plus decay of radioactive isotopes, which produces positrons. Antiparticles are also present in cosmic rays and the solar wind. Although nowhere near as abundant as regular matter, harvesting antimatter from our own solar system may enable humans to gather antimatter at a lower cost per gram, but it will still be for the foreseeable future an extremely expensive thing to obtain. So for now, antimatter is an intriguing concept which is already being used in a variety of applications. However, we still undeniably have much to learn about antimatter, how we can safely use it, and what it can do for us. Hopefully, no antimatter bombs.